In this video, we're going to cover coding in statistics. So a lot of people really don't like to do coding because it's tedious, it has a lot of steps, but it's very simple. And the point of coding is to really deal with these big numbers that we have, and we condense them into a code. These intervals get condensed into a code, which we denote as U. And we deal with U's and the frequencies and figure out our mean, variance, and standard deviation. And then we'll go into graphical representation of these values that we have here. So let's begin this question. So part A. Now the question is given with these two columns over here. But I would advise you to add these next 1, 2, 3, 4, 5 columns to your table and fill them out, and then have your net FU or UF and net U squared F. Once you get these values, you can apply the mean formula and the standard deviation or the variance formula to calculate those values. So anyway, what I'm going to do is show a sample step of how to calculate this box, this box, this box, and the remaining boxes. So we'll start off with this cell over here. X is the midpoint of the class interval. In this case, it's the midpoint of this class interval, which is 1.4130 plus 1.4134 over 2, which is equal to 1.4132. So that's 1.4132. U is calculated by the formula x minus a over c. X we have, which is the value over here. A is the value of the midpoint of the interval with the highest frequency. So the interval that has the highest frequency, right away we're going to denote as u equal to 0. And when we define this, we set a equal to the midpoint of this value. So the midpoint of this in this question would be 1.4152. Anyway, so if we want to find the value of u for this class interval, we're going to do x minus a over c. The c is 1.41, the width, 1.4135 minus 1.4130, not the width between this number and this number, but the width between this number and the next number that starts the next interval. So in this case, the c value is equal to 0.0005. Okay, so in this case, u is equal to 1.4132 minus 1.4152 over 0.00505. We have 1.4132 minus 1.4152, 0.0005 minus 4. See, we're just converting these long complicated numbers into a code, and you'll realize that there will be patterns. These numbers will increase by 0.0005, I think, and this will be increasing by +1. U times f, so frequency, right? The number of times we have flour bag in this interval is 3. 3 times minus 4 is minus 12. And then to get this value, we can either take the frequency and multiply it by minus 4 whole squared, or we can just multiply this column by this column. So anyway, 3 times 4 squared is what, 16 times 3 is 48, or 4 times 12 is also 48. And this capital F stands for cumulative frequency. So this column would be 3, because that is the cumulative after this interval. After this interval, it's 8. 3 plus 5 is 8. And then we have 23 plus 8 is 31, so on, so on, so on. And the last one should be 200, because there are 200 flour bags, and cumulative is 200. So I'm going to go ahead and fill out these values. And when you're doing this question in the midterm or the exam, you should show a side work of how you got these values, and then you can say, following the above steps, I went on and calculated the rest of the values in the table. Okay, so now I've filled out the table using the side steps that I showed you, a few seconds ago. And now I'm going to calculate the mean. Now you have to remember that the mean of the u's is pretty much the u times frequency, add them all up, and divided by the number of flour bags we have, which is 200. So we're gonna multiply these and add them up. Therefore, we're just gonna have this column over here, u times frequency, which is this column, and we're gonna add them all up, which is net uf, which equals to 2. And then we have u squared times f. We're gonna need this to calculate us variance, which is 456. Now the mean of u is simply 2 over 200, but we don't want the mean of u, we want the mean of x. X bar is equal to a, which is 1.4152, which I explained earlier, plus 0.0005 times net uf, 2 over 200. It's simply 1.4152. If you approximate it, you'll get this number. Because this number is so small, I mean, it'll probably be like, if we calculate it, 0.0005 divided by 100. 2 over 200 simplifies to 1 over 100. So yeah, that plus 1.4152. We have 1.415205. You can say that's our exact mean. Now the variance is equal to c squared times variance of u, which is 0.0005 times, I'm gonna write it here because I'm gonna run out of space, net u squared f minus net uf whole squared over n minus 1. So yeah, this is our equation. So, but don't get so caught up in calculating this that you're gonna forget the c squared. Make sure you multiply the c squared, or the variance of u. We're gonna have 0.0005 squared times u squared f is 456 minus 2 squared over 200 over n minus 1. N is our number of flour bags, which is then equal to 57.8 or 57.28 3919 times 10 to the power of minus 8, or you can write e minus 8. Therefore, our standard deviation is equal to square root of variance, which is equal to 0.00076. So we got our variance, and this is our standard deviation. It's pretty straightforward, very simple. Coding isn't hard if you know the procedures. The only thing is that you need to make sure you don't make any silly mistakes when calculating the frequency times u, or the adding up the net UFs and the net U squared F, and applying it in these equations. The only thing you have to worry about is not making silly mistakes, and coding will be just very straightforward, easy marks. So we'll go on to the graphical representation part of this question.